Welcome back to Namaste Node.js. And in this episode, we are going to see the code of all this, right? In the last video, I explained you how basically Node.js functions, how different components of V8, libuv, and operating system and all these things work in tandem with each other, work in sync with each other to execute your JavaScript or Node.js code. Everything works. So I explained you in detail, in theory, in diagrams, in how basically works behind the scenes, what is the meaning of asynchronous IO, what is non-blocking, what is main thread, how call stack works, how memory heap works, how garbage collector works, how libuv works. Everything I explained you, right, in theory, in diagrams. Now I am going to actually show you the code for all of it, right? I will show you the code for all of it. So remember that if you go back to our previous lectures, so I showed you that this is a synchronous code, this is a async code, and I showed you basically how do you basically run the synchronous code and all, right? So how synchronous code happens. Let me just quickly revise it and then I will actually show you in the code editor and run the code and actually show you that how this code is running. Okay, so you know that, okay, just a quick revision that, okay, this is a synchronous code and it can be executed just by a V8 engine. It does not need help of any superpowers or Gini or libuv, anything, right? It can just quickly execute it. It's a synchronous code and time, tide, and JavaScript waits for none, right? So it will just quickly execute that code, isn't it? And all these things will work in sync. So let me just show it to you. Let me go back, and here I have already written this code. Okay, so this is the same code over here, right? It is kind of like the same code, right? I have written console log of hello world. I have where a is equals to this, b is equals to this, multiply, and right. So if I will do node, right? So I have created multiple files to show you code demos. So if I do node and if I do sync, right? The file name is sync.js. If I do sync.js to show synchronous code, now when I will hit enter, right? When I will hit enter, just see that how fast JavaScript engine will execute this code, okay? How fast I am hitting the enter, my dear friends, okay? This is the keyboard, I am hitting the return statement, 3, 2, 1, hit. And see this, quickly, JavaScript engine executes the code quickly. And behind the scenes, you know what happened? You already know, right? It created the global execution context, and then global execution context was pushed inside the call stack, and then it executed the code synchronously line by line. Then multiply function call was made. Now functional execution context was put inside the call stack. Now function code was executed, and this code was executed. Then this function, whatever it returned, went to C, and it allocated the memory meanwhile. And V8 engine is also doing garbage collection behind the scene. Everything V8 engine is doing to run this code is happening in a quick microseconds. This is how fast quick runs, right? JavaScript code is run. This is the power of synchronous code, and V8 engine handles it very cool, right? V8 engine handles this code very smoothly in a very fast fashion. Do you see this? Let me just run it once again. See how quickly it runs. I hit enter and barely I have to wait for few micro milliseconds and it returns me the result, isn't it? It returns me the result, my dear friend. That's how this synchronous code is working, right? And then later on, we also see that, okay, that basically if we want to access this, so V8 engine cannot do all of this, right? V8 engine needs a help, and then when you need a help, when you need some superpowers, you need a Genie, you need a superhero to access all of this from the OS, and that is when we realize that, okay, V8 engine offloads all of this to libuv. Right? And if we move ahead and if we see that, okay, whenever you see any API call, a file read, or a set timeout, all this code is basically simply offloaded to libuv, and libuv basically talks to the OS to make it work. Now, let us just see. I showed you this example. If you understand this example, you will understand that how large thousands, millions of line of code is run also. It's also run in the same way. Right? Whether you have a 10 lines of code, whenever you have 100 lines of code, whether you have a million lines of code, if you understand this concept, you will understand everything how JavaScript code is run. Nothing fancy behind the scenes, but that's how it works, right? So this is what I explained you in theory. Now I will show you this running in your code, right? So if I go over here, let us go to the file async.js. In async.js, it is the same code. Whatever you have seen over here, this is the code written in this async.js. And if you will see over here what we are doing, let me just show it to you again. Okay, cool. Let me just show it to you. So basically what we are doing, we are requiring a file system, right? We are requiring this HTTPS module because if you have to, so basically these are separate modules. So you'll have to require it before you can use it. So this is how you basically read file and you execute some code, right? And I am doing a console log hello world. Basically this is the starting of the program. Now I am assigning, I have mixed matched the code, right? So basically this is A, this is B. I am making an API call now, right? So now I am making an API call. So I cannot make the API call to fbi.com, right? But I have taken a dummy API to make an API call. Also in setTimeout, I have given 5 seconds, right? Once the 5 second passes, this should happen. And then I have also seen that, okay, fs.read file. So you have to read a file and this is file.txt. If you will go, I have created a new file over here and this file, this is the file data. Okay, I have just put in some dummy data over here. Okay, just a very small file just to show you how things work. This is how I have done. Now, and later on, it's the same code, right? You have a multiply function. It multiplies the value of A and B on the top, right? And then it calculates the result, return the result, and prints the multiplication of the result. Got it? Now, let us just see how these things work, my dear friends. Okay, let us just see how this code works. So if I execute it, so how this code works, first of all, let us just see how will this code execute, right? So I have shown you already, but let me just quickly recap it once again. Let me recap it once again. So see, first of all, this line will be executed, A will be printed over here. So let me just dry run the code, not here. Let us just do it here. Okay, let us just do it here. Okay, so what will happen is, okay, so let us just find the output of this code. How can I do that? Can I create a new file, new text file? Okay, so I've created a new text file. Let me write it here. So, okay, so this is not this file.txt. Sorry, my bad. Let me create a new text file over here. Okay, this is a new text file and this untitled, let me just move it here. I want to do this here, right? Okay, cool. So output. Okay, so basically this will be the console output. Okay, just wait for a minute. I'm trying to show you in a way that you will not forget, right? I will explain you in a way that you will not forget. Okay, so this is where I will write the output. Now let us first dry run it. See, let us not run this code, first dry run it. Okay, so what will happen is JS engine will start executing this code. Okay, so it will execute this, it will execute this. Now you know, right? Require function, I told you in previous videos that require function works in a synchronous fashion in your common JS module system. Do you know this? Right? Hope you understand that. Where is the common JS? Wait. Let me just show it to you. Right? If you have understood this, see this. You know, require function. Where is require function? Yes. Common JS uses require function and this require function works in a synchronous mode. Synchronous. ES module can work in a asynchronous mode. So if your interviewer or if I ask you, how will this code execute? You know what to tell, right? So basically over here, when you do this, this code will run in a synchronous fashion. Okay, this code will run. All these will come in a synchronous fashion. All these files are loaded. Now we have got access to our file system and I have got access to our HTTPS. Now what will happen? Now the JavaScript engine will move to this line. It will do console log and our console hello world will be printed, right? Hello world will be printed, right? Isn't it? So I am just writing the output over here. Hello world. Okay. This hello world is printed. Now it will go back to A memory store, right? It will go back to B. And now meanwhile, all this is happening. There is a global execution context which is running over here. Isn't it? Now, as soon as V8 sees this line, now it's time to call our Genie. It just calls the Genie. Hello libuv, make an API call. So it just offloads this task to libuv. libuv takes this callback function and it stores it with itself, right? Libuv takes this callback function A and it stores it with it, right? And then meanwhile, JavaScript engine start executing the next line, right? JavaScript engine now has nothing to do with this. It just moves on to the next line, right? It quickly moves on to the next line. It says that, oh my God, it's a set timeout. Give it to libuv. Now libuv will register a set timeout, right? It will register a set timeout and it will register the callback function. And now libuv will do the manual work of calculating when things will work, right? So libuv will wait for it, right? And then similarly, JavaScript engine sees the next line fs.file read and it will just move it to libuv, and now libuv will read the file. Okay, now JavaScript engine moves to the next line. It sees it is a multiply function. It does not do anything. It just stores this multiply function into the memory, right? And then goes to this line. Now we see, okay, multiply function needs to be executed. Now it goes back, find the data from the memory and then start executing this code. Once JavaScript engine executes this code, it calculates the result, return this result, and meanwhile all this is happening inside your functional execution context. Global execution context is still sitting over there. Right? Now all this functional execution context pops off the stack. After doing this, garbage is collected from the garbage collector. All this temporary. See, this is a temporary variable, right? This result is a temporary variable needed only when this running the function. So garbage is collected. Now what will happen? The value is assigned into C. Right? Now the C memory is assigned and a value is assigned into the memory heap. Now do we do a console log multiplication result is, and then we calculate the value of C. Basically now in our console, we will print the value of result is and whatever the result is, some numbers, right? Over here, so there will be a very big number which will come up. I think this is the number, right? Let us take this number. Now our output will be hello world and multiplication result is this. Okay. And now all the code is executed. Now JavaScript engine is sitting idle. It has executed, this code will be executed in just few nanosecond, microsecond, milliseconds, okay? Very fast it will execute. Now the responsibility is of libuv to make this API calls, and once the API call has returned, it gives back. Once the FS system is returned, gives back, site timeout happens, gives back. Now, these can take their own time. These are running in parallel and it can take their own time. Suppose file system is read now. Right? Suppose the file system. See, out of these three tasks, which task will be executed first? Tell me. Which is the fastest among these three? Which is the fastest among these three? See, to make an API call, you will have to make an API call. It will go to the network, fetch the data, come back. And API calls generally take your 100, 200, 300, 500 milliseconds, right? So, and set timeout is of 5 seconds. 5 seconds is a very long time. This is the longest task, okay? This is the longest time. This set timeout is going to take forever, right? 5 seconds. It just takes 5 seconds. It will take like 100, 200, 400 milliseconds. File reading. You don't, when you read a file, right? You don't have to make an API call to the network, get the data and all, right? File is over here only, right? In the operating system, file.txt, I have to read the file which is there in our folder, right? So it is again not that slow, right? So what will happen, what I think and what I am telling you is that file reading will happen very fast. This is the fastest among the three. Then API call and then set timeout. Okay, so basically file system will take right around, I think 10-20 milliseconds to fetch the file, right? And 10-20 milliseconds. And this API call might take 100-200 milliseconds. And this set timeout might take its own time, right? 5 seconds. It will take 5 seconds. Cool. So let us see. So what will happen then is, suppose file reading take 10 seconds. So see, this code, this full code, how much this full code took to V8? It might have taken like 1 to 5 milliseconds or something, right? It will take very fast, it will execute. So very fast is executed, all this is outputted. Now, suppose after 10-20 milliseconds, the file is read, because so it also depends on how big the file is. This file is very small, it will just take 5-10 seconds to read it, right? So this data is coming, right? So now, once this file read is completed, so this callback function C, this callback function is just pushed inside the call stack. right? Now this callback function will run, and this callback function will print to the console file data and the file data. What is the file data over here? What is the file data over here? Right, what is the file data over here? File data is the data which is returned from the file. This is the file data. So basically this data will be printed like this. Cool. And what will happen in async? Then what will happen after file is read? Then API call return. Now this file data is read. Now this is gone, right? libuv is no more managing this. Okay, now API call will happen. Meanwhile, the API will return the result. Now this function A will be pushed into the call stack. Okay, so now this console.log A fetch data successfully will be printed onto the console. Okay, so fetched data successfully will be printed onto the console. Got it? And now, similarly, after 5 seconds, now it will take a long time. After 5 seconds, set timeout, this will be printed onto the console. Now you know the execution order. This is how the output will look like. Right? Now, shall I show you? Shall I run the program and show you the results? I have cleared the console. Shall I show you the results? Let's say node and async.js, right? Async.js, let me save the file. I don't know what I edited, but save and let me run it. As soon as I will hit enter, you see the result, right? I'm hitting enter in 3, 2, 1, enter. Do you see this? Do you see this? Now, oh my God, do you see this execution? Just see this execution once. It was very fast. It all happened in 5 seconds, but what happened is, see this. Now let me hit enter. Hello world and multiplication and file data is printed very fast. Then it took some time to fetch the data and set timeout. See this. See that it's quickly executed. Now after some time, fetch data successfully is called. After 5 seconds, set timeout is called. If you will notice, then these first three lines will be printed fast. Then it will take some time. Then fetch data successfully will be called. Then it will take some time. Then set timeout will be called. Got it? Let me just show you once again. Let me clear the console. It is very tough, right? Because this JS engine executes everything very fast. That see, everything is happening. Whatever I shown you is happening over here. Global execution context, but it's very fast. As a teacher also, it is very tough to explain you this, right? See this. Now let me just run it once again. The first 3 lines will be printed very fast. See this. And then it will take some time to fetch data. See this. 3 lines. Now the 4th line, data is fetched. Now set timeout will happen. See this. Let me run it again. See this. Now the data is being fetched. Data fetched. Now set timeout after 5 seconds. See. This is how it will, play with this code. I will push this code to GitHub. You will find the GitHub repository link into the, wherever you are watching this video, right? On Namaste Dev platform, you will get the GitHub link, right? Or go to the GitHub repository of Namaste Dev official. Over there, I will push all this code. Play with this code. Or else don't even, why do you want that repository also? Write this code yourself. Write this code. See and write this code yourself in your system and run it. Play with it. You will be amazed. Just see how it works. Just see how it works. Right? See this. File is also read very fast. Suppose this file was a very huge file. Suppose this file was a very huge file, maybe 100 MB file, 200 MB file, 500 MB file. Then it might take some time to render that file also, right? This file is very fast. So what can happen is, suppose there can be a case, if the file is large, there can be a case that API call might return earlier. So API call might take 100, 200 milliseconds, but the file might take much more time. The file might take much more time. So in that case, this output can be different also, right? But what I'm trying to say is, JavaScript engine main thread is not blocked. All that heavy duty task is being offloaded to libuv. That's how things work, right? So play with this code, you will love it. I'm telling you, you will love it, my dear friends. Hope you are liking this, right? I wanted to show you this. Now, let me actually show you the blocking code, right? Let me actually show you. Let me close this up. Okay, can I close this? Okay, or maybe what else I want to show? I want to show one more thing. Wait for it. Let this console output be here. I want to show you one more demo before moving on to another demo, right? One thing is, see, when you do fs.read file, it offloads it to libuv, right? But if you, because why? Because this is a async function. Async function, right? This is a async function. Okay, this is a async function. It just offloads it to libuv. But there is a way, there is a function which is known as fs.readFileSync, right? There is a function which is known as readFileSync, and it takes a path. Let us give it the same file path, right? And let us also give it a format. I want to read it in UTF-8. Now don't worry if you don't know about UTF-8, just Google it. Be curious about things, right? What is UTF-8? I can ask you that question, right? Go read about it. I'm not telling it right now because I'm explaining something else. But what I'm saying is there is a function just like read file. This is an async function. This is a synchronous function. What do you mean by a synchronous function? Synchronous function. This function will actually block the main thread. This function will actually block the main thread. This function will actually block the main thread. What do I mean by that? So see, now you might be thinking, Akshay, oh my God, you added another level of complexity to the code. Yes, I did, because that is how complex Node.js is. And it's not complex, it's fun. It's fun to see how things are working behind the scenes. So what I'm telling you, how JS engine runs the code, it sees that, okay, https.get, yes, it's async. Transfer it to libuv. Okay, that's how JS engine works. HTTPS get libuv, setTimeout libuv, fs.fileRead libuv. But when you get read file sync, suppose if you get read file sync, now JS engine, now it's like a sync function. That means libuv does not, V8 engine cannot offload this task to libuv. V8 engine cannot offload this task to libuv. Right? So basically, or you can assume that, okay, and let me write this on the top, right? Let us say that I want to block it, right? I cannot go further. Okay, let's put a console log over here, right? And then this console log will only happen after the file is read. If this call takes 100 milliseconds, still the code will be paused for the moment at that point of time. Now you can ask, Akshay, will this sync function block the main thread? The answer is yes. Will this sync function block the main thread? Yes. Will V8 engine offload this to libuv? The answer is also yes. The answer is yes. So basically, see, file system capability is not there with libuv. File system is capability is not there with the V8 engine. So it has to offload the task. But meanwhile, file system is getting the data in a synchronous fashion. There is a way that JavaScript engine will not move ahead. This is basically blocking this. Now you might be thinking that, Akshay, how will JavaScript engine be blocked? You said that, okay, V8 engine quickly executes thing. See, when file system API was being created, there were certain scenarios when this library wanted to implement this method in a synchronous way. Suppose if you are a developer, and suppose you want to basically run any piece of code only after, basically you, suppose let me give you an example. I showed you the example of a restaurant, right? See, to run a restaurant, there is a synchronous way and there is a asynchronous way. Now, what is a better way? Obviously, asynchronous way is a better way. But suppose if you are a stubborn developer, right? Or maybe you are a stubborn restaurant owner. You say that, okay, I want to just serve first come, first serve, right? I want to just do first come, first serve. I want to run my restaurant in a synchronous way. You can run it, right? You can run it. But you should know the consequences for it. It will block it. It will block the queue, right? It will just not let other people pass in. It's your call, right? So similarly, as a developer also, when this file system module was created, when this FS module was created, so V8 engine and Node.js gave you the capability, okay, it's your job. If you want to block the main thread, block it. I don't care, right? Block your main thread by doing this, right? By doing this sync. So as a developer, we should never use this sync method, but still they are available for use. This is what I want to say. Right? Now, everything looks good in a diagram, but at the end of the day, it is code which is running behind the scenes. And this functionality is given to us by this FS module, right? This FS module, that you can run it in a synchronous way. Right? You can run it in a synchronous way. You will block the main thread, and this will happen on the main thread. Okay, now JS engine to run any piece of JavaScript code. Okay, so the code will block on this 10th line. The code will block on this 10th line and only will pass ahead once the file is read. If the file is taking 100 milliseconds, 1 second, 10 seconds, it will just be stuck. Your main thread will be stuck. This is blocking IO. That is why you should not be doing blocking IO in your system, and as a good developer, you should not be using this function. Just for the demo purposes, I am showing you this function, just to show you how things work. Now, this will execute only after file read. Okay, this will execute only after file read. Right? Let me just run in the console and let us see the order of execution. So if you will go run node async, so see again, and now once hello world is printed, after that this will, so after hello world, the program would have paused for a while for reading this file, because this file is very, this file is very, this file is just a very small file, right? So it just happened quickly, so it is unnoticeable over here. It is unnoticeable over here, right? If I show you over here in console, it is not noticeable, but it is actually blocking the main thread. Okay, this is what you have to understand. Your knowledge should be there. Okay, let me just show you one more example where I will show you actually, right? Let me just show you a blocking code example also. I just wanted to show you that there is an API for blocking also, right? If you want to do that, you can do that, right? So, okay, this is the file. Let us go to this code, right? Blocking.js. Let me show you one more demo. Over here, you will properly see I will block the main thread. It will have to wait, right? I'll just show you the main thread, okay? So there is a library which is known as crypto. So whenever you do require crypto, we did in async also, we did require FS, require HTTPS. I am doing require crypto. So what is this crypto? Crypto basically, see, all these are Node.js core modules. These are Node.js core modules. Now you know what is modules, right? Go to Node.js documentation, right? Go to Node.js module documentation, and in the documentation, if you will go, you will find all these modules over here. See, there is a HTTPS module over here. There is a file system module over here. Similarly, there is a crypto module over here, and there are more crypto modules. There are more modules over here. More modules over here. These are extra utilities which Node.js gives, right? Remember, I was telling you, right? So over here, this Node.js does not just have your V8 and C, libuv, right? It also has a lot of other major things, right? So similarly, these modules are also there. FS module, HTTPS module, crypto module. There are so many more other modules. See, this is the best place to find the documentation, right? This documentation is the best place to find anything. There is a DNS package, there is a domain, there is a error, there is a events. So many things are there. We will see all of them, right? Not all of them. We will see most of them. Slowly, we will see all of it, right? There is even a module which is known as console, and this is where you do console.log. When you do console.log, where is that console coming from? That console is coming from here. A lot of Node developers does not even know that, right? Why? Because they have never seen the documentation. But if you will read the documentation, you will know all of this, what is happening over here. right? There is a OS also, right? There is a rep. You saw that rep, right? When you run the node and it runs in read, evaluate, print loop. This is coming from here. There are so many more. If you'll go explore it, you will see this. This is zlib. What is zlib? This library is used to make compressed files. Suppose if you want to take a file and compress it, you can do it via Node.js core module zlib. This is used to compress files. It will create a compressed version of your file. You can do a lot of cool things, my dear friends. So whenever you are writing any require, that means you are calling this crypto module, and this is a module which is present inside Node already. It is automatically given to us. This is again one of the superpowers. Not just V8 and libuv. There are more superpowers Node.js gives to us. This is one of the superpowers. This is crypto. So whenever you are importing a core module, you can import it like this, or you can also write something like this, node colon, right? So node colon crypto, it's one and the same thing. Node colon crypto and crypto, it's one and the same thing. And similarly, if you go to async, you can also write node colon fs, right? If you will run the code, it will run the same way, right? It's one and the same thing. So some people just skip this, but you can write this if you want to also. This means that it's a core module. It's a core Node.js module. Okay. I want to tell you all these small things also, because you might go and work in a company, and in the company you might find somebody is writing like this. You as a developer should know what is happening over here. It's an optional thing to write over here, but this is how you include your core modules. Got it? Now, this crypto gives you a function to create a key. This crypto is basically gives you function. Suppose if you are creating a password, suppose if you are generating a key. So, right, you can generate a key, right, for a password using this function, which is known as pbkdf2, right? Sorry, pbkdf2, right? This pbkdf2, there is a crypto. If you'll write crypto over here, it gives you access to a lot of functions and keywords, right? See, it says that create hash, you can create a hash, you can create a HMAC, create a private key, create public key, create sign, create verify, generate a key, generate a pair, generate pair sync, and all these functions that you are seeing with sync in front of it. See, there is a generate prime, there is a generate prime sync. Whenever you will find sync written in front of anything, that means it's a synchronous function. It will block your main thread. And all these functions are non-blocking by default. Similarly, there is a function which is known as pbkdf2, right? This is known as password based key derivative function. Okay, so it's a very long one, right? So let me show it to you. Password based key derivation derivative function. I know this word is very complex and a lot of people don't even remember this. You don't have to remember this, but understand that, okay, this is a function which will generate a key if you give it a password. If you will hover this, see, this is pbkdf2. This provides provides an asynchronous password based key derivation function 2. It's a version 2. See, a selected, read more about it, right? If you want to, right? Read more about it. And it has come since version 0.5.5. It is there in the library, okay, in the crypto library. And if you'll go and see this function, it will take a password, right? It takes a password. I'm giving the password as password, or you can give it hello world, or if you can give it password 123, whatever you want to give, just give it, right? This is a password, and you'll have to give a salt, right? There is a salt for encryption. There is a 50,000. Now this is iteration, right? Let me close this up. Don't save, okay? So there is a iteration. This is known as iteration. If you'll see, the third parameter is iteration. Iteration means how many iterations how much more complex you want to make your password, right? This key, how much complex this key should be, right? The more this is, the stronger stronger it is. So stronger it will be to decrypt. right? So that's the more iterations, the stronger it is, right? Basically, the tougher it is to do it, right? Crack it, sorry, right? And then this is digest. So digest means which algorithm you want to use. I want to use SSA 512, right? And then what is this 50? This 50 is the number of key length, right? This is key length, right? So the key should be of how much length? So suppose this key will be generated. This key should be of how much length? This key should be of 50 length, right? There should be 50 should be the length of this key. And you get a callback. So once this code is executed, now let me tell you that, see, this crypto is also an async function, and this is also managed by libuv. Okay, so just like whenever you saw an API call, whenever you saw a file system, whenever you saw a set timeout, it offloaded to libuv. Similarly, whenever you see a crypto call, it will offload it to libuv. Okay, so this is also managed by libuv, and libuv also registers its callback. And once it has generated the key, it calls the callback back, right? It throws the callback into the call stack, and it is executed very fast. Okay, so that's how these things work. Okay, so I have explained the code to you, and it's the same code which we have seen. Let me clear the console and run this file first. How will you run this file? Node blocking.js. Okay, so now, right now it's not blocking, just the name of the file is blocking. That is why I am showing you. Okay, so if you generate this, see this, if you generate this, how the code was executed? First of all, hello world is printed. Now, as soon as it see crypto.this file, so this code is offloaded to libuv. This task is offloaded to libuv. This callback function is given to libuv, and then the code executes. It logs multiplication result, and then later on, once that password or that key is generated, then this callback function is executed and key generated is printing. So the sequence is hello world, multiplication, and after the key is generated, it comes back to the call stack and it prints the log. But let me just suppose, I want to block my main thread. Okay, so I can use a function. This is an async function. Okay, this is an async function. This function is an async, async async function. Okay, so what is the full form of pbkdf2? This is password based key, and this is a function, right? Async function. But there is a synchronous function also which is present, right? There is a synchronous function also present over here. I wanted to show you that, and I want to block the main thread, right? So crypto.pbkdo f2, and you will see that there are two functions, pbkdf2 and pbkdf2 sync, right? If you will add sync over here, right, this function will basically block your main thread. This function will block your main thread. If you will see, it will take these things, right? It will, and you will see, right, all these sync function will never have a callback, right? This sync function, see, if you will, this is a async function. See, there is a callback. Over here, there is a callback function. These all sync function never have a callback. They will have this password salt and then iteration, key length, and this digest, right? But it will not have a callback over here. Why it does not have a callback? Because the libuv is now not registering a callback, and there is no concept of callback, right? Because there is no point of callback. The main thread will hold on till it is generating a key, right? And basically now you can just do a console.log. The key is generated, right? First key is generated. First key generated. Okay, so now this is a sync call. So what will happen? Hello world will be printed. Now what will happen? Now this cannot be offloaded to libuv. It is not a async task. What will happen? This will wait till the key is generated, and then it will print first key. Then when it reaches this line, it will offload it to libuv. Then it will print multiplication result. Then once the key is generated, this key generated is printed. Let me just show it to you. Run the code. See how this will work. Right? How this will work. Clear? Now let me run blocking.js. If I run blocking.js, do you see? Do you see this? Okay, I have not saved the file, I think. I have not saved the file. Let me rerun it. Let me clear it. Let me clear this console first. Oh my God. Okay, let me clear the console. Let me run it once again. See this. Now what happened? Hello world, first key is generated, multiplication, and then the key is generated. The second key is generated. Okay, that is how it works. Right? So this is how it works. Now you understood the concept. You know, a lot of people don't even understand that why this is printed first and then this is printed after multiplication result, right? But you understand it, right? It is very complex for teachers to explain this, right? Now a question can be, why this multiplication? This is the last line of code. This second key generated is printed at the last, right? If you'll see, the second key generated is printed at the last and first key generated is printed the first because it is a sync operation. Now let me show you blocking the main thread. Now let me show you why I use this pbkdf2 method is because this password key generation is a very CPU intensive task. Right now I am just doing it for 5 lakh iterations. What if I increase the number of iteration? If you will increase the number of iteration, right? If I increase the number of iteration to 50 lakhs, so now this task will take a lot of time to do. And you will actually see the thread blocking. You will actually see the thread blocking. Let me show it to you. If you run the code now, see this, it waited, right? Now hello world is waiting. And it took a lot of time for the first key to generate. It took a lot of time to first key to generate. Do you see this? It will wait. My main thread is being executed. The code cannot run. The multiplication and all this cannot run. It is running in a synchronous fashion. See this. See this. Let me just run this. See this. Now it is waiting. Waiting. First key is generated and then everything happens very fast. Right? Now, what if I suppose, see, my second key generation also takes some time. Suppose if I add one more 0 to it, now the second key will also take some time to generate. Okay. So now see this. Clear? Now let me go to blocking. See this. It is waiting. Now the other code is executed. Now it is waiting for the second key to be generated. Now the second key is generated. Do you see? The main thread was blocked, my dear friends. The main thread was blocked. This is what I wanted to show. So never ever use sync methods. Synchronous function will block the main thread. Don't use it. Right? Don't use it. Don't use these functions. I don't know why they even exist. I think they exist for teachers like us to teach you how to block the main thread. Okay. So don't use these methods. Right? This is how it works. And suppose if I add one more 0. If I add one more 0, let us see. Right? It will block forever. Right? So let us just clear the console. Okay. And if I go back, now it is waiting. It will keep on waiting. Right? It will take, these iteration is not a joke. Key generation is a CPU intensive thing. See this. Till now it has not generated the first key. Till now it has not generated the first key. It is kind of like blocked forever. Think of this written in production. V8 engine is like struggling right now. The job of V8 engine is to just execute the course very fast, but you have, see, now after so much time, this first key was generated. V8 engine, you are just, it is like suffocating the V8 engine when you are doing this, right? This line is basically suffocating. It's like holding the V8 engine. You are giving a choke slam to V8 engine right now. Okay. So never write blocking code. This is just for demonstration purposes. But what I want from you is to go back, my dear friends, and please go back and just run all this code in your system and execute it, play with this code, understand why it's working, move it up and down, mix this crypto file system, all these mix things up, and then see how things are working. Right? So lots of amazing things are there. right? Lots of amazing things are there in Node.js, and hope you are loving this code and Node.js, right? With this, let me come to the last portion. Let me come to the last portion of this video. Last thing which I want to explain, and then we will take a pause, we will take a leave. But what I want is, my dear friends, just watching these videos will not help you. You will have to go to the code and run it yourself. You'll have to block the thread, block the main thread, and then see how things are working. Block the main thread and see how things are working, my dear friends. Got it? So this is how things are. And now, okay. Okay. So one more thing which I wanted to show you is set timeout over here, right? Set timeout 0. So there is a concept which is known as set timeout of 0. You have always seen that if I write suppose if I write 3 seconds, so how will this execute, right? I will explain you this concept of set timeout 0. How will this code execute, right? How will this code execute? This whole global execution context will be created. Hello world will be printed. Let me create another file. So this can be a output question in your interview. That is why I am showing you this, right? Explaining you this console, right? That is why I am explaining you this, and it's an interesting concept. People sometimes don't understand this. The developers struggle to understand this. That is why I'm showing you all this, right? So, okay. So now, suppose if you have this code, how will it run? First of all, hello world will be printed. You know this already, hello world. Now what will happen? This set timeout will be offloaded to libuv, right? Offloaded to libuv. Right, and it will wait for 3 seconds. Meanwhile, the code will be executed and then multiplication result will be printed, right? Hello world, multiplication result. Once 3 seconds expire, call me ASAP will be printed. This you know, right? This you already know. Call me after 3 seconds. After 3 seconds will be printed. Call me after 3 seconds will be printed. Got it? This you already know. Now, if I run this function, in which order these output will be printed? Tell me. Call me after 3 seconds will be printed, right? So if I go back and if I run this Node.js and set timeout 0 file, so see, hello world is printed, multiplication, and then after 3 seconds, call me after 3 seconds is printed. It's very easy. You already know this. But what if I do a set timeout of 0? What if I do a set timeout of 0? What does it actually means? It says that wait for 0 milliseconds and execute me. Call me as soon as possible. ASAP. Call me right now. ASAP. Call me right now. Call me right now. Right? I want to be executed after 0 milliseconds. I want to be executed after 0 milliseconds. Now, what will be the order of execution, my dear friends? Tell me. Hello world, and then this code will run, and then this set timeout will be offloaded to libuv. Now, libuv sees that, okay, this is 0. This is 0 milliseconds, right? Now, the libuv will see that, okay, this set timeout is 0 milliseconds. So, will this B function be just sent to the call stack immediately? When will this, do you understand? If suppose the set timeout timer is 0, right? So then this callback function needs to be pushed to call stack, right? So can it push to call stack very soon? Can, right? What will be the order of execution, right? Or the JavaScript engine will execute full code and then later on it will print this. Let me show it to you. What will happen, my dear friends? A lot of people are confused when they see this type of code. And the answer is, hello world, multiplication result, and call me right now. It was supposed to be called right now, right? At this moment only it was supposed to be called, but this does not happen this way. It does not happen this way. Why? Because this is an async operation. and it goes to the libuv, and libuv can only get this callback method to be called once the call stack is empty, once the call stack is finished executing all the code, right? First of all, JavaScript engine in the global execution context will execute the full code, then only it can execute any callback. All these callbacks which you will see, right? Whether it is 0 millisecond, whether it is immediately call, whatever it is, it will only execute once your global execution context is out of the call stack, right? So all this code will be run even when it is 0 milliseconds, even when it is 0 milliseconds, still, my dear friends, this code will run after some time, right? After the whole code is printed. So how will the execution happen now is, it will print hello world, this callback will be registered into libuv, setTimeout will be registered to libuv, and then this multiplication result is printed, global execution context move out of the call stack, and now once the call stack is empty, this function, this callback will only be pushed to call stack in V8 once the call stack is empty. If the call stack is not empty, if the global execution context is not finished yet, it cannot happen. Okay, this function, this callback function cannot be run. Okay, so this is what I wanted to show you over here. And you know, that means setTimeout has trust issues. There are trust issues in setTimeout. Why do you have trust issues in setTimeout? Trust issues with setTimeout, right? Why we have setTimeout trust issues? Why? Let me tell you why there are setTimeout trust issues. So whenever you say you want to run this code, whenever you say you want to run this code after 0 milliseconds, does it actually run after 0 milliseconds? No. It does not actually run after 0 milliseconds. It only runs after 0 millisecond when the call stack is empty. 0 milliseconds after call stack is empty. There is a terms and condition applied. In setTimeout, there is a terms and condition applied. Have you seen that? Right? Have you seen? Right? So setTimeout has a terms and condition. Right? setTimeout has a term and condition. Right? setTimeout comes with a small star on the top, that whatever delay you will give to setTimeout, that will happen. That is a terms and condition applied. Only if the main thread is empty, after that 0 seconds. See, I have given 0 seconds, right? It should have been immediately executed, but this is a false thing. It cannot happen this way. That is why I say there are trust issues with setTimeout. You know, so, and do you see, let me show you a fun example also. Suppose if you go to this blocking JS, and over here, see, this password takes a lot of time to be generated. Now let me go back over here. Let me remove 10 also because it will take a lot of time. So see, ideally, call me right now. This is like struggling. This is dying to be called. Call me right now. Right? But will this be called right now? No, it will not be called right now. It will only be called once main thread is not blocked. Main thread is empty, right? Main thread, call stack of main thread. Let me write it down full. You should know the lingo. Whenever I am saying call stack, in your mind, you should know what I am talking about. If I am saying call stack, you should know what I am talking about. If I say memory heap, you should know. Garbage collector, you should know. Right? You should know. It will only be called once call stack in the main thread is empty. Call stack of main thread is empty. What is main thread? Main thread is this. Main thread is where JS engine is running. Got it? So, but I have over here blocked the main thread. Right? I have over here blocked the main thread. So what will happen now? Right? What will happen now? This is choking the V8 engine, right? This is basically like you're actually choking the V8 engine right now. Okay? So let's just call it up. Let me clear the console first. So node, and then you will have to call this blocking, right? This blocking script. If I run this blocking script, see this. Now it is waiting. Now the program is waiting for the first key to be generated, and this call me right now is just laughing in the corner, right? Call me right now is just laughing in the corner. Okay? Call me right now is just gone, right? V8 engine is choked. We have blocked the main thread, and then call me right now is cannot happen. Call me right now happened, and then the second key was generated. So basically, there is a trust issue with set timeout. Never ever think that whatever you give, whatever delay you give to set timeout, the code will be executed after that time. It will be executed as soon as possible. This will be executed as soon as possible. What does it means? In the terms and condition, it is written that as soon as possible, right? As soon as the main thread is empty, right? This will be run as soon as main thread is available, right? So this is how code works behind the scenes. Hope you would have understood it. I have explained you how sync code works, how async code works, how set timeout 0 works, how blocking, what I mean by blocking the main thread, what are sync functions, non-sync functions. I wanted to explain you all these concepts, right? I wanted to give you a code demo in this video. I wanted to show you how sync code works, how async code works, how blocking the sync code, right? Blocking and sync code. I wanted to show you call set timeout 0. I wanted to show you what is non-blocking IO. Non-blocking IO you already know. You know what is main thread. You know what is asynchronous operating IO. You know, I have shown you the GitHub repository of libuv, right? I have shown you already like the GitHub repository of libuv. So all these things I wanted to cover in this video. I have covered all of that. I hope that your understanding of Node.js is becoming very good. You are starting to love Node.js. You are starting to know why Node.js is so popular. With just one thread, my dear friends, it is able to do a lot of things. When you run Node.js on a server, when you create a server, HTTP server, and then there are so many people visiting your server, Node.js still works in a very fast way. This V8 engine, this single thread can handle a lot of things in a very fast way. Trust me, this is a very superpower over here, which I have explained to you, right? Are you loving Node.js or not? Tell me. Are you loving Node.js or not? Tell me now. Are you loving or not? What I want to say is go practice this up. The more you will practice, the more you will learn, the more you will write code, the better you will understand, the more you will love Node.js. As a teacher, my mission is to make you fall in love with Node.js, and I will do it. If you are not yet fallen in love, if Node.js is just your crush right now, you will fall in love slowly. And that is what I want to do in this video series, in this whole web series, Namaste Node. I will make you fall in love with Node.js. I will make you realize the power of Node.js. I will make you realize it has been over decades, 15, 16 years, more than 16 years when Node.js has been in the market, and still it is one of the most powerful technologies what we use on server. This is the reason. It's amazing. It's amazing, my dear friends. At the end of this video, I just want to say, I want to request you one thing. Please, please, please share about Node.js on social media. Maybe you can share the learnings, whatever you have learned in this video on social media. Maybe you can just write, appreciate us, appreciate me, tag me, and write about Namaste Node.js, or share your knowledge on social media. Tag me along. I would love to read your post. Please do that. It just helps me. It just helps us grow. Just spread the word of Node.js out in the social media. That will be a great help for me. And I will keep teaching you. It takes a lot of time, my dear friends, to prepare all this, to make this series, to teach you. And only small request is if you can share about the word to your friends, to your family, to other people. That will be a great help from my side. That's all in this video. Thanks for watching. See you in the next video where I will explain you more amazing concepts. Bye-bye till then. See you.